Okay, welcome back. What I want to look at is electronic safety. Electronic safety. Now, electrical safety, electricity can be dangerous. Okay, if you don't follow proper safety precautions, electricity could kill you. Now, that's common sense. But don't ignore this part. Safety, safety, safety. Now, some of you would have done the health and safety with myself in the classrooms. Okay, don't ignore those lessons you have learned. They are vitally important if you were going to be an electrician or whether you're going to be an electronics engineer. It is the same criteria. The principle of safety matters. The 1 to 10 to 100 rule. The 1 to 10 to 100 rule states that you can feel 1 milliamp or 1 part of 1,000 amps of current through your body. 10 milliamps is sufficient to make your muscles contract to the point where you can't let go of a power source. And 100 milliamps is sufficient to stop your heart. This is a rule you should learn and respect. Do not ignore it. Okay, now again, you would have learned these requirements in regards to health and safety, in regards to being an electrician. Those safety rules still applies here, being an electronics engineer as well, should you choose to go down that area or that path. Now, let's look at resistance of the human body. Resistance of the human body. The human body has a resistance of about 500,000 ohms. This value is a somewhat ideal figure for contact with a small area of dry skin. Now, moisture and sweat on your skin will lower the resistance to a value nearer 5,000 ohms. Now, contact with a greater area of skin, for example, gripping a wire between your fingers or grasping a pipe, or grasping a pipe will further reduce resistance. If you were to immerse your hand or foot or puncture the skin so that the electrical connection is made with your more conductive blood and tissue, the resistance could be as low as 100 ohms. Now, so here we have a situation where your body is almost becoming part of a conductive circuit, and you have to bear in mind that once you have become part of that conductive circuit, it is very difficult for you to release that cable that you may be holding on to. Your muscles then will begin to spasm, and because it is a sinusoidal wave from switching on and off at 50 cycles per second, the chance of you removing your hand from that source is highly unlikely. So therefore, it's important that when you're an electrician or whether you're working as an electronic engineer, that you're always working with someone within proximity to yourself. So if something goes wrong, they can identify it and is in a position to help you. It may even save your life. That is not likely if electricity passes from finger to finger through your body, along your arm, and so forth. However, Your heart and brain are considerably more sensitive. Current that passes from hand to hand or through your head is much more likely to cause death. Electricity passing elsewhere through your body could cause an electrical burn. Okay? So again, keep this in mind. And I'm just going to bring this in closer as I can so that you do not underestimate what this is trying to say. Now let's look at safety precautions. You should always follow common sense safety precautions to avoid electric shock. These precautions include: don't touch exposed electrical contacts with any part of your skin, touch only insulated handles, leave covers on equipment unless you need to access the internal components, work one-handed. If you use only one hand, electricity is less likely to flow through your body, specifically your heart or head, and cause injury or death. Okay? Now when they're saying here work one-handed, it simply means that if you are dismantling, let's say, a video recorder, for instance, you simply need to make sure that the video recorder is unplugged for start. But remember that capacitors hold a charge, so you could still have an electrical charge within your video recorder unit or your DVD unit. So what the idea here is to make sure that if you're dealing with that component that you're using, one is placed on some kind of safety mat, two, your other hand is securing the unit but with the assistance of a pair of gloves or even another mat to support the device, thereby making sure that one hand is not connected to anything else, and while you're actually using the other hand to unscrew or to check the system. Never insert anything into a wall outlet other than a power cord. Rings, watch and jewelry can cause unintended contact with electrified components. Furthermore, here again, take notice of jewelry, especially hanging chains from your neck, because I can tell you this, that a hanging chain from your neck entering into a active device, whether it be a video recorder, a DVD unit, a power amplifier or something of the sort, or even a control panel system, can cause you extreme agony. Remove all rings from your hands. Okay? Put them into a safe place, leave them in your pocket, leave them in your bag if you need to. Do not take items of metal with you in your work environment. It is not in your best interest. Keep your hands clean and dry at all times, okay? Do not work with electricity in wet surroundings, especially wet floors. If your floor is wet, make sure it is cleaned up. Again, remove all rings. Work one-handed, as I've said before, what that means in that sense. Touch only insulated handles and parts of tools. Okay? Electrical measurements. You might be called upon to measure some aspects of electricity, such as the voltage level output by power supply. When you do so, make sure to follow common sense safety precautions. Now, multimeters. Now, I'm not going to talk a lot about multimeters here, because if you look at my channel, You'll see I've given you a lot on multimeters already, how they work, both analog and digital. Okay. Now, analog multimeters, they all the type display the output using the needle and dial. Digital multimeters output discrete emit values on an LED or LCD display. Okay. And look at my channel in regards to multimeters. It states it there already, and you'll find it in the electrical principles section. Now use the playlist as well, because what I've done now is to bring these into a playlist, so you can run the playlist. Just look down the playlist and run them individually if you need to get familiar. Okay. For me, dealing with electrical work expanded my understanding and my need to move into electronics. So I then moved into electronics and studied electronics to HNC level. Okay, so I do hold an HNC in electronics. Now, static electricity is a phenomenon in which the charges on separated objects are unequal. One object has an excess positive or negative charge as compared to the other. Typically, the objects are made of an insulating material, one that doesn't transmit electricity easily, or a conductive material that is insulated from ground. Sorry about that, I was just off cue. The charge imbalance creates an electric field that can cause objects to attract or repel. Now it depends, if they will attract if they are opposite poles, north and south, and they will repel if they are the same type of poles, north to north, okay, or south to south, each other. Okay, sorry, let me just run that again. The charge imbalance creates an electric field that can cause objects to attract or repel each other, such as when a static field makes your hair stand on end. From the perspective of a PC technician, the most interesting and dangerous aspect of static electricity happens when statically charged objects are brought near each other. When that happens, a current can flow between them to balance their charges. This current flow is characterized as a high voltage but low amperage. Okay, so although you have a high voltage, the current is quite low. So the effect here then is simply will cause you pain more than anything else. Now let's take into account static discharges, or I should say static dangers first. The current flow. Static discharges aren't dangerous to humans, even though the voltage in the system can measure in the range of thousands of volts. However, such discharges are potentially harmful to electronics. The microscopic wires and components that make up chips and other devices, logic gates, etc., transistor systems, are very sensitive to even small amounts of current. A static spark can melt such components, rendering them useless. Smaller discharges can alter the data stored in chips or otherwise upset their operation without causing physical damage. Right now, the damage here in regards to chips, logic chips, is that it can cause your chip to probably trip to a logic 1 or logic 0, depending as to the state the chip was in before the static discharge happened. Okay, that means that it will give you false reading or cause an operation to occur that was not intended. Discharge voltages. To feel a static shock, you experience a discharge of approximately 3,000 volts or more. Discharges of more than roughly 8,000 volts might generate a visible spark. Walking across a carpet on a dry day can generate a charge of as much as 35,000 volts. Yet, electronics can be damaged by 1,000 volt discharge or less, a third or less than the minimum discharge you can feel. What that means here is that if you're dealing with electronics and you're the electronic engineer and you're working for a company, if you do not take into account static discharge, you can end up causing massive damage to the electronic systems within that company, and you will be held responsible for that. So you need to take account of that actions. Static problem prevention. Now here we're looking at how to prevent it and what measures we need to bring into place to cure it. There are two ways to prevent problems from static. Prevent the buildup of static charges, prevent discharge the charge safely. So what we're saying here is we can prevent the discharge, we can prevent the discharges, or we can discharge the charge static electricity safely to ground. Prevent static buildup, okay? You can follow these steps up to reduce okay, we can, yeah, sorry about that. It's okay, so I just lost my bearing for a moment. Just bear with me for a second. You can follow these tips to reduce the buildup of static charges. Don't shuffle your feet as you walk. Increase the humidity in the room or buildings. Static charges can dissipate before growing large if the humidity level is sufficiently high. Keep yourself grounded as you work and move around using the tools found in a typical Esd kit, such as wrist straps shown in Exhibit 3 to 3. These I have shown you. I will show you later on as we come to the end of the session, so you can see what that actually look like. Wear cotton clothing, which is less likely to generate static charges. Now bear in mind that nylon clothing generates a static charge, okay? Remove carpeting from rooms where you service computers. Use an air ionization system to build up an opposite and thus a neutralizing charge in the air. Okay, prevent static discharges. If a charge differential does build up, you can follow these tips to prevent or reduce the likelihood of damage from static discharges. Equalize the charge safely. Unplug the computer. If you must move around as you work, keep yourself grounded with an anti-static wrist strap, as I will show you once we get closer to the end of the session, so that charges can build up. Your goal to prevent damaging discharge is to be at equal charge potential with the device you're servicing, not with ground. You should not leave the computer plugged in while servicing it. Again, remember that capacitors within your component device will hold a very high charge in themselves. and they have a habit of flashing across. Okay, that will not be in your best interest. If there were a fault in the building's wiring system, full wall current could be flowing through the ground wire. You could be injured or killed if you came into contact with the ground. Okay, so again, all it is saying here is reminding you that the static charge should be grounded in its own right, not through anything else. The need for robust electrostatic discharge. Need for robust Esd protection. Now, designers of portable systems are constantly challenged to make smaller devices with increased functionality. To do so, semiconductors have to become more complex, requiring sub-micron processes and very fine line widths. Now, what that means is that sub-micron is that we're operating in the micron stages. These are like operating at an atomic level, basically. Okay, so we can go, in this case, we can go to 1 micron, 2 microns, 3 microns, and so forth. So we are dealing with a very small scale processing, a very fine line width. And these lines, when we say here, it's fine line width, mean that the distance between the connections are almost that close that they're almost touching, but not quite touching. Okay. In turn, they become increasingly more sensitive to the effects of electrostatic discharge, making matters worse in the race to provide more and faster functionality on chip. Esd protection is by necessity being sacrificed in favor of chip performance. It is expected that the integrated circuits of tomorrow will not sustain the current levels of on-chip Esd protection. Okay, now tomorrow has already come. We're here already. Okay. As on-chip protection reduces, ICs will become even more sensitive to the effects of electrostatic discharge, Esd. With increased Esd sensitivity of digital ICs, the need to protect systems with more robust off-chip transient voltage suppression will be greater than ever. Now, portable systems are constantly exposed to the damaging effects of electrostatic discharge, Esd. An unsuspecting user can inject a hazardous charge during normal device operation. The consumer usually perceives system failures as poor quality. Device sensitivity coupled with increasingly miniaturized form factors have increased the challenge of designing adequate Esd protection. Okay, adequate Esd protection. Now remember, if you're a company and you're selling your products, if the customer suddenly has a problem and it's touched your, let's just say for argument's sake, his DVD, and he was electrically charged and dispenses a ESD to his device. If that device then blows, he will consider that to be poor quality, because although he may have discharged through that device, it's important that that device was not receptive to that electrical charge. So it is in the company's interest now to make sure that ESD does not affect their products. It requires a combination of good board layout and state-of-the-art protection components to properly complete the task. Now, equipment for ESD protection, and here we have a wrist ground cords. Okay, so look at these, and that's what you would be using. They'll simply be plugged into the workbench or some sort and clipped to the unit, and it's keep it grounded. Okay, here again we have another one, longer cord, doing a similar task again. These you can change the crocodile clips in it or make them larger or bigger depending on what you want to do. Let's bring that into close again so you can see it. Okay. Okay, I'll just go to the little pen out a little bit. Okay. Here you have your wrist strap, which that's your wrist strap on your hand. Okay, one of these leads then will then plug into it and be bonded down to ground. Okay. Okay. And here you have some anti-static mats as well, which can be used for a similar purpose. Okay, to prevent static buildup. Okay, all I've done here is to answer some questions. Okay, and I would like you to answer those questions for me, please. So once you've done those questions, I'd like you to show me that you have answered them. Now remember, you can answer these questions in Microsoft Word or in your laptop or your iPad or whatever you choose to. But look back at the information, make sure you understand the concepts behind it. Safety, safety, safety first. Okay, I think that's it. Let me just slide back a little bit to make sure that we have got everything in. Okay. Okay, we seem to be good. Okay, again, let me just make sure bring those in closer to yourselves. See them in full. Okay. Just make sure that you can see everything and that everything has been accessed by the camera. Okay. Again, remember, you need to write this out for yourselves to make the work your own. Okay. Do not just ignore it or assume that you can read it from the screen. This is not your work. To make it your own, take the time to write it up. Then do some additional research for yourselves with a line in with regards to that specific question, so we have an update and keep your work updated at all times. Okay. Okay, it seems like we have everything in, so I'm going to take all the way to the top to make sure that it is clean and it's being brought to the attention of yourself. That'll be it, okay? Right, thank you for your time. I hope you found this useful. You have a good day. Bye bye.